Hello, am I audible? Hello,
Yes, sir.
shall we start the class? People are still joining, but you have 9 a.m. you have class, so I'll finish this class by 8:50. Okay, so if this is visible, this PDF.
Yes, sir.
This PDF is available with you, right? Hello, this PDF is available with you. I sent it yesterday. Is it there? Have you got this PDF? Your seers are supposed to send you this.
Yes, sir. We got.
Okay, let's start the class. So today we will discuss stability of a four-wheeled vehicle. And first of all, what do we mean by stability? I have just drawn a vehicle here. Here you can see a vehicle which has four wheels. These wheels are shown here. These four wheels are there, and the engine sometimes its flywheel is also along this axis. So the rotating components in a vehicle, four-wheeled vehicle, they are shown here. Now, what do we mean by this stability of a four-wheeled vehicle? What do we mean by stability? Because these four wheels are touching the ground, that means the ground is also giving some reaction on these four wheels. Now think about at a situation where the reactions from the ground on the wheels is negative. What will happen? The ground, the wheels, what is the condition for touching? The wheels will touch the ground, always in contact with the ground. What is the condition? What is the condition that ensures that the wheels are in contact with the ground? What is that condition? The reaction from the ground has to be always positive. That is the condition that the uh, wheels are always in contact with the ground. Is this point clear to you? Or shall I repeat it?
सर
Hello?
रिपीट कर दीजिएगा.
Ah. So I'm saying that suppose a vehicle is running on the road. Okay. So the we want the wheels must have always in contact with the road. What is that condition which ensures this continuous contact of wheels with the road? What is that condition? The condition is any wheel which is getting a reaction from the ground. Obviously there will be some reaction because of many forces, not only the weight when it is taking turn, and the centrifugal force, the gyroscopic action, all those actions will be acting through these wheels to the ground. Okay, due to that there will be reaction developed between the ground and the wheel. Okay, that reaction, when that reaction is positive, that means what? The wheel is in contact with the ground or with the road. But suppose that reaction, which is reaction between the road and the wheel, suppose that reaction is negative. So this direction, we are saying that this direction, this reaction is positive. Suppose that reaction is zero, crossed zero. this reaction is negative. That means what? That means there will be no contact. Okay, you understand this? So suppose the vehicle is uh, the vehicle is running, and this vehicle, the condition, there is a condition. So just look at this uh, mobile phone and imagine that this is the vehicle. The vehicle is running, going forward, and then it is taking a turn. It is taking a turn like this. So there is always a chance you have felt it while traveling through a vehicle. There is always a chance it can topple in this direction, or it can topple this direction. We will now examine what is that condition when just before, what is the condition which ensures no toppling. Okay, so that condition we will find out here. And that condition is this reaction force has to be always positive. If this reaction is negative, then the condition for toppling is there. Just imagine when the vehicle is toppling, so one side of the vehicle first loses the contact with the ground. Okay, those suppose those are the inner wheels or outer wheels. Inner wheels means when it is taking left turn, inner wheel. Sorry. So suppose the vehicle is like this and it is taking left turn. When it is taking left turn, the wheels which are in this side, we will call them inner wheels, and the wheels which are this side, they are outer wheels. Okay. So we have drawn the same figure. This vehicle is taking left turn. Suppose the vehicle is taking left turn. So when is this vehicle taking left turn, I have just drawn all the wheels here from the top. If you just see from the top, this is the wheel 1, wheel 2, the two front wheels, and then wheel 3 and wheel 4. These are the two rear wheels. Okay, and the engine rotating component also I have shown here. Okay, you can argue that in some trucks the engine flywheel is not always along this axis, they are along this axis, but we are taking in the cases where the flywheels are flywheel of the engine or rotating component of the engine, they have the same axis, this axis. Okay, now the the vehicle is traveling forward. So the rotational direction is this direction. It is rotating about this axis, and this is the axis of speed. So we will call this axis as Z axis, and the whole vehicle is taking a left turn this direction. It is taking a turn like this in this direction. So actually about the axis, vertical axis, it is having this precision. Okay, in this case the axis is perpendicular to the plane. Okay, and what about the axis about which the moment is applied moment due to this gyroscopic action, the externally applied moment, that is this x-axis. Here it is shown, it is on the plane, but it is acting this way. So this is z-axis, this is x-axis, and perpendicular to the plane of this paper, that is the y-axis or capital Z-axis, and that is the precisional axis. Okay, so now we have discussed what is the condition for stability, and we have discussed what are the rotating components of this vehicle. Now we will see what are the reaction components on each wheel. 1, 2, 3, 4, 3. So the four wheels are there. All those four wheels are in contact with the ground, and if you if you draw the free body diagram of these wheels, the isolate from the ground, then what are the reactions, different reactions which are acting on each wheel? That's what we want to now draw. First of all, one by one we will see. Suppose these wheels we have drawn separately. This is wheel 1, this is wheel 2, wheel 3 and wheel 4. So first let us take what is the reaction due to its own mass. The whole vehicle has its mass. So all the masses, the weight should be supported by the four wheels. So suppose the total mass is m. So the total weight is mg, and this mg will be supported equally by four wheels. So mg by 4 is the weight on each wheel. So what is the reaction due to the weight? Suppose Rw is the reaction on each wheel due to this weight. So that means Rw is mg by 4. Okay. Now what is the direction of this mg by 4? Obviously mg is acting downward. That means the reaction is upward on the wheels. The reaction by the road on the wheels. Okay, is this clear, this point? So we have shown on each wheel this Rw is same in acting upward. Are you fine with this?
Yes, sir.
Now let us take another component of reaction. That reaction is due to gyroscopic action. Why there should be a gyroscopic action? Because you see all the wheels, they have their rotational axis is this z axis, and they are taking a turn which is this left turn. That means this axis is having a rotation about some vertical axis. Due to that rotation, the angular momentum vector is changing its direction. So due to that, there should be some applied moment. What should be the direction of applied moment? In this case, can you tell me what should be the direction of applied moment if for one wheel or for one set of wheel, 1 and 2? What should be the direction of
X-axis.
applied moment? Eh?
X-axis.
X-axis. This is the x-axis, right? And you no need to remember why this is about x-axis. Just see about z-axis, the angular momentum vector is there. So when it is taking this left turn, this angular momentum vector will come to the new angular momentum vector will be this much. So what is the change? The change is along this direction, but that is the x direction. That means applied moment direction should be along the x direction. Okay, so applied moment direction is along the x direction. Okay, that means there should be there should be two forces which is creating a couple, that is this mg. Okay, in this case those two forces are rg. Okay, so in wheel 1 and 2, if the rg forces are acting this way and this way, that means in this axle it is creating this moment mg. Are you fine with this, with the directions of rg on the wheels? Because this is the applied force, externally applied force. This externally applied force on the wheels must create this moment. Okay. Are you okay with this? The directions of RG? Hello?
Yes, sir.
So 1 and 2 are the front wheels. So front wheels, the set of front wheels, there this RG is acting. Similarly in 3 and 4, because we have taken all the wheels are of the same weight and same speed. Okay, because the radius is same, so that means the reaction, set of reaction in the rear wheels also the same. So this is
Sir,
the
sir, why in a wheel 1 and wheel 2 the reaction of force RG has different directions?
why क्वेश्चन फिर से बोलोगे?
सर आरजी का डायरेक्शन जो है व्हील 1 और व्हील 2 में डिफरेंट क्यों आ रहा है?
Okay, different क्यों आ रहा है? Because what is the purpose of this RG? This RG has to create a couple which is equals to this mg. So
Yes.
without, है ना, Without,
Yes, sir.
if they are not in opposite direction, they cannot create a couple, right? Equal and opposite, so they are creating this couple, Mg. Fine.
Yes, sir.
So similarly, Rg, the same thing is for 3 and 4. Okay. Now, what is left is the reaction due to centrifugal force. Since it is taking a turn, there is some centrifugal force which is acting in the system. So suppose in the road, this at a height h from the road, that is the center of mass of the whole vehicle, the wheels, the body, everything. Whole vehicle has a mass m, and the center of mass is at a distance h, at a height h from the road. So, what is the total centrifugal force acting on this center of mass? That depends on the turning velocity, okay, which is, let's say, omega p is the turning angular velocity, and it is taking a turn with this radius r. Okay, so that means m omega p square r is the total centrifugal force. So this centrifugal force is creating a moment about this ground, and it, since this force is acting on the center of mass, it is at a distance h. So that means we have to multiply with h to uh, get the moment due to centrifugal force. Now just see here, this the consider this color, whatever this color which is not red, the vehicle, we have drawn the vehicle, and the force, centrifugal force due to the left turn, the centrifugal force is in this direction. That means the moment created which has this direction, okay, the moment created which is this direction. But when you consider what is the reaction due to this moment, what is the reaction in the wheels? The reactions would be in the opposite direction, right? So this RC are the reaction. RC are the reaction due to, means to resist the centrifugal force, or say the moment due to centrifugal force. Are you convinced with the direction of this RC? These RCs are the reaction on the wheels. Just I have shown two wheels. Okay. The centrifugal force is acting this way. That means the moment due to centrifugal force is acting this way. That means there is a force due to centrifugal action that is acting downward, and here it is acting upward. So the reaction from the road is just equal and opposite. So the RC is acting upward here, and RC is acting downward here. Are you convinced with this? Is it fine? Is it fine?
Yes, sir.
Okay.
Yes, sir.
If it is so, then you just see. I have shown here. Suppose this is wheel one and this is wheel two. So RC is acting downward in wheel one, and RC is acting upward in wheel two. That's what we have shown. RC is downward here. RC is upward here. Okay. And the other case, 3 and 4, they'll have similar way. RC is only thing you just see here that we for RG and RC, we don't know what is the value of RC and RG. We have just shown the what is the direction. Okay, for RW we know what is the exactly, we know. We can find out this RC, that we will do later. But right now we have just shown what is the direction of these reactions. Okay. Now, so in each wheel, you see just when it is taking a left turn, you see just this configuration and this configuration, they are same, right? So 1 and 3, they are same. 2 and 4, they are same. Because 1 and 3 are the inner wheels. So if it is taking a turn in the left turning, it is taking a left turn. Just Just so when it is taking a left turn, as I said, these two wheels, this is 1 and 2, the front wheel and rear wheel, these two wheels we'll call inner wheels, and these two wheels, the wheel number 2 and 4, they are outer wheels. Okay. So the inner wheels, they have similar kind of reactions, and the outer wheels, they have similar kind of reactions. Now let us add all these reactions. So if you add the inner wheel reactions, you'll see what you see. This is RW. RW is positive minus RC minus RG. Same thing for wheel 3, but wheel 2 you see RC plus RW plus RG. Okay, so this way we have here written the reactions of on each wheels. Okay, inner wheel and outer wheel. Now you see from this outer wheel reactions, all the directions are positive. That means it is always positive. It will not never be negative. So the the condition for stability due to the outer wheels, okay, for stability Ri and Ro, the reaction in the inner wheel, reaction in the outer wheels, they should be greater than equals to 0. Ro from the inspection, we can see that this is always greater equals to 0. But we have to check then what is the reaction in Ri. From this expression, we cannot say that this is always greater than equals to 0. But for stability, this has to be greater than or equals to 0. Okay. Otherwise, there is a chance of toppling. पलटी खा सकते हैं, ठीक है ना, vehicle. So let us now find out these expressions for this RG and RC. RW already we have obtained. Now we will find out what is RC and RG. First, let us consider what is RG. So the gyroscopic couple in each axle. So in each axle there are two wheels, right? In each axle, what is the gyroscopic couple? There are two wheels. So that means you can say that the total moment of inertia is 2I multiplied with the angular velocity of the wheel, the velocity of spin, and then velocity of precision. Okay, whatever the turning angular velocity, that is this. So total moment which is acting on one axle is this due to wheels. But the gyroscopic couple in each axle due to engine, because there are two axles, है ना? दो axle ही है ना? There are two axles but one engine. There are two axle but one engine. Due to this engine, there will be some couple, some gyroscopic couple will be there, but that must be divided by two, है ना? Because that couple is stabilized by the wheels. So the total gyroscopic couple due to this rotation must be divided by 2. So in each axle, the gyroscopic couple due to the rotation of engine or rotating component of engine is this, which is equals to half the moment of inertia of the engine, rotational velocity of the engine components, and then the precisional angular velocity, which is the turning angular velocity. Okay, so these are the two moments which are acting on each axle. So total gyroscopic couple in each axle is just addition of these two. Sometimes this can be a this minus this. Why? So if the rotational direction spin is just opposite to the rotational direction of the wheels, then you have to, it will be just negative of that. So In this case, we are taking a positive case where the wheels rotation and the rotation of the engine components, they are in the same direction. So we'll just take positive. But remember that it can be a negative sign. If it is negative, it will be given in the problem. So when you add them, you have this expression. Now this expression is the moment gyroscopic couple which is acting on each axle. Okay, so then what is the reaction in each wheel due to that? So the reaction is if the two wheels are at a distance W, two wheels are at a distance W, that means Rg into W must be equals to Mg. Okay, that's what we have written here. So Rg equals to Mg by W. That is the reaction in each wheel. Up to this, if you have any problem, ask me. Are you okay with this? The expression of Rg, which is this by W. W means the distance between two wheels on one axle. Is it fine? Hello?
Yes, sir.
Now the next work is we have to find out what is the centrifugal force. So already we have shown that this is the centrifugal force, total centrifugal force acting on the center of mass of the vehicle. And this reaction must be divided, this couple must be divided by 2 so that we can get the couple in each axle. Okay, this must be divided by 2 so that is the couple in each axle. Okay, now what is the reaction in each wheel? So MC by 2 is the couple in each axle, and since the two wheels in each axle they have a distance W, that means the reaction RC is MC by 2W. Are you okay with this? ये ठीक है? This is the total couple, but this couple must be divided by 2 because there are two axles. Okay, in each axle the wheels are at a distance W. So W into RC is equals to MC by 2. ठीक है?
Yes, sir.
Yes, sir.
So now we write the expression what is the reaction in the inner wheels. If you remember, the expression is RW minus RC minus RG. ठीक है? That's what we have written here, RW minus RC minus RG. Okay, so what is RW? Mg by 4. That's what the first expression we have obtained for RW. RC is this is MC by 2W. Okay, and RG already we have obtained this expression. You can check it from here. This expression divided by W. This expression divided by W. So that's it. This is the total expression. Now, in a practical problem, all these values will be given. So you just put all the values and see whether this Ri is greater than equals to 0 or not. If it is greater than equals to 0, there is no problem. The vehicle is the motion of the vehicle is stable. But if it is less than 0, then there is some problem. The vehicle will topple. So that depends on all these quantities. Mainly you see that depends on this quantity, which is the precisional angular means. You will see that sometimes when you are riding a bike or car, you are taking a turn, you have some intuition that this much velocity I should have, other than there will be some issue. Some when you are taking a turn, you will see that with your bike you are taking a turn or vehicle you are taking a turn. in the turn you slow down, right? Why you slow down? There is not only the not only the centrifugal action, the gyroscopic actions are also there. Okay. So the speed, you need to control the speed, and those speeds are written here. So this toppling depends on this expression. Okay, now we take one example, and I have not written the statement of the problem. There is a four-wheeled vehicle, and these are the given data. This given data, the total mass, here the data is little bit modified on one wheel axle system. So this M is given, this is the total mass on one wheel axle system, that is 1800 kg. So suppose it is a four-wheeled vehicle, that means this into 2 is the total mass. But problem is little bit simplified. It is saying that in one axle wheel axle system, this is the total mass acting. So when you find out the reaction due to the total weight, that means this must be weight must be divided by two wheels. Okay, the distance between two wheels in one axle, that is 1.6 meter. So generally this is a problem of a railway wagon. Uh, so there is a banking angle. The problem which we have discussed right now, there is no banking angle. It was on the horizontal face of the road was horizontal. But in this case, in the problem, it is given there is some banking angle, and that banking angle is 10 degree. Okay, the vehicle is taking a turn which is left turn. It is taking a left turn, and the radius of that turn is 24 meter. Mass of a pair of wheels with axle, whatever the rotating mass. Okay, this you can consider this axle is rotating in a railway wheel axle system. You'll see that the axle is a rotating component. These wheels are also rotating component. All of these three components, they are rotating about same axis, and due to turning, the whole system is rotating about a vertical axis. This whole system has a mass of 180 kg, and this whole system, which is a rotating, its radius of gyration is given here. A radius of gyration of rotating components of each wheel axle system. Height from the ground, the height is 0.95 meter. The radius of the wheel is height of the center of mass. It is saying height of the center of mass from the rail or from the road is 0.95 meter. Radius of the radius, it is given 0.3 meter, and so radius of the wheels is given 0.3 meter, and the velocity of the vehicle is 10 meter per second. Basically, from this velocity, as we did earlier also, from this velocity you can find out what is the velocity of angular velocity of spin, right? So omega r, omega s is the spin velocity. Omega s into r is equals to v. From there you can find out what is the omega of the wheel. Also, since this radius is given, so it is taking a turn. So that means this r multiplied with the precisional angular velocity is equals to this velocity. So so from here, these two angular velocities you can find out. So we need to determine what is the pressure on each rail. So it is a railway wagon problem. So in each rail, what is the reaction? Okay, that's what we have to find out. So basically there are three components of reaction. One is due to weight, another is due to centrifugal force, another is due to the gyroscopic couple. Okay. So now we have drawn this figure, one wheel axle system. Since there is a banking in the road, the railroad, there is a banking, this angle theta equals to 10 degree, it is given, and this height is also given, center of mass and the road, rails, the distance is given. First, let us go for this, RW. We have here written inner wheel and outer wheel. R RIW means reaction due to weight in the inner wheel, reaction due to weight in the outer wheel. So the total weight here, you see the total weight mg is acting downward due to banking. The component of this load is mg cos theta, which is acting this way, and that component is balancing these two reactions. So that means these two reactions must be equals to mg cos theta. So if you take moment of all these forces, so in the center of mass, the weight is acting downward. It has two components in the two perpendicular directions. And now if we take moment of all the forces, we have this equation. Moment we are taking about this point B. So this reaction RIW multiplied with this distance W, the distance between two wheels, W, okay, that is acting this direction. And mg sine theta, this is mg sine theta multiplied with this distance. This moment is acting in the opposite direction. Now mg cos theta, from this point to this point, this distance is w by 2. Okay, so that is also acting in this direction, which is okay opposite to this moment. Right. Then if you that must be equals to 0. So from here we can find out what is RIW. So what is ROW? That we can find out from this. Just substitute this expression here, so you'll get ROW. Those expressions are written here. Now let us go to the next part, that is reaction due to centrifugal force. Here again we have drawn the figure. These are the two wheels. This is the axle. This is the center of mass. At the center of mass, the centrifugal force is acting this way. This is the horizontal force, the centrifugal force. And we have drawn the components of that centrifugal force. Since the banking angle is theta, this angle is theta. So now again, the reaction, you can have a question here. You have given the reaction directions are like this. Actually, we don't know what is the reaction here due to centrifugal force. These are two unknowns. Okay. And from these equations, from the force balance here, force and moment balance here, we can find out these reactions. Okay. If these directions are, we have taken this direction which is not correct, then in the solution they will come negative. Okay, we no need to care about which direction we have taken initial. So we have drawn the free body diagram, and now these two reactions from this diagram, you can see that RIC and ROC, the reaction due to the centrifugal force in the inner wheel, reaction due to centrifugal force in the outer wheel, they must be balanced by this force. That's what written here. Now we will take moment of all the forces about this point P. If you take that, then it is written here RIC multiplied with this distance, that is one component of moment. Now another component will be this multiplied with W by 2. Another component will be H multiplied with this. That's what we have written here. We got the equation, and from there RIC, its expression we got here. The reaction in the inner wheel due to centrifugal force. Okay. Now, once we have this, we will use this equation to get the reaction on the other wheel, the ROC. Okay. This way, we got the expressions for reaction in the inner wheel and reaction in the outer wheel due to centrifugal force. What is left is the reaction due to gyroscopic action. Now remember the case for stability in the two-wheel vehicle. where the precisional axis and the spin axis, they have this angle, which is here. If you see this, this is the horizontal axis and this is the axis of the spin. This horizontal axis, they have this angle theta. That means from this diagram you can see that the angle between the precisional axis and spin axis is 90 degree plus theta. That means in the original expression we have to substitute theta plus 90 degree. Let me go back to original expression for the gyroscopic couple or the moment due to, yeah, this is the expression, right? In this expression we have to put theta equals to 90 degree plus theta, and we will assume that this quantity is very small. That's what we did for the stability of bicycle here, and we got the expression mx equals to I, these two angular velocities into cos theta. Expression is valid for this wheel axle system, and in this wheel axle system we have written the gyroscopic couple is I omega w, means this we have written omega w, that is the angular velocity of this whole rotating thing, and this is the angular velocity of precision multiplied with cos theta. How this expression came, we have discussed now. Okay. Now, once you have this expression, you know that this is the applied moment along the x direction. That means from from outside of this wheel and axle, there should be a couple acting which is equals to this, and that couple must be created by this set of two forces. This set of two forces and this set of two forces. So this must be acting in this direction, this must be acting in this direction. Then only it can create a moment like this. Okay. So then the total gyroscopic couple M equals to this expression. You can write down this expression where this I, if you remember, it is given that the radius of gyration for this whole rotating thing, that is given, that is k, and the mass of the whole thing is given, that is m. So mk square is the moment of inertia of this system, and as we have discussed, v by small r gives you the rotational velocity of this wheel and axle, everything. V by capital R gives you the precisional angular velocity multiplied with cos theta, which is 10 degree, you know. So all these values are given. That means this M is known to us. So what is the reaction then? Simply these are the two forces which are creating couple for this gyroscopic action. These two reactions are equal and opposite. So the reaction Rg multiplied with W must be equals to M. The value of M is now known to us if you substitute the values. So Rho, the now you can find out Rho, which is the total reaction in the outer wheel. Total reaction in the outer wheels. Just see from here. You see this is from here. This is ROG acting upward, ROC acting upward, ROW acting upward. Okay, so then you add all of them, ROW, ROC, ROG, all of them are acting upward. The values are already obtained, so you can just substitute here, get the reaction in the outer wheel. What is the reaction in the inner wheel? The inner wheel reaction for this case RIG acting downward, so we have written it minus that. And if you remember RIW and RIC, here RIC we have taken upward. Whether the value is positive or negative, that depends on this calculation. Okay, but we have taken it upward. So in the final expression we are taking, this is also upward the reaction. So that is why the inner wheel, these two components we have added upward, and this component did downward, and all the values are given, so you can substitute this and can find out the reaction of this on these wheels. Okay, this is exactly 850. I will stop here. If you have doubt, you can ask me right now, or if you have no doubt, it's fine. You can ask me questions if you have doubt. So some practice problems, right now the institute website they have changed, so all those handouts may be not available. If you have already downloaded, the problem sets are available with you, right? Have you downloaded the practice problems from my web page? Hello. So this is a book. Can you hear me? Hello.
Yes, sir.
So this
Yes, sir.
already I have shown you. This book is Merriam and Craig. The book name is Engineering Mechanics Part 2, which is Dynamics. It has a chapter. It has a chapter 7, which is Introduction to Three-Dimensional Dynamics of Rigid Body. Actually, everything which is taught here in a nutshell I have completed through this chapter. Whatever I taught you last 4 or 5 classes are from this chapter. Okay, not exactly, the presentation may not be the same, but this way. So the problems which are given in this chapter, the theoretical background, the theory which we have discussed in the class, you must be able to solve all this problem. But when you go on solving this problem, you will see the difficulty. You will see that how much uh, this subject, this topic is involved. And for example, we can go to this. The last section of this chapter is called gyroscopic motion, steady precision. Okay, let us see some of the problems, how the example problems and the solve and the practice problems are there. This book is available online. You can download problems. You see, this is a there is an instructor who is showing. I have shown you a toy which behaves like this. A string is there. Some related problems are there, but these are the simple problems. But you see, there is a fan, as we have discussed. The fan with a swing. That means you need something to balance here. Those problems are there. Some more complicated problems are there. This is the problem of spinning top. This is a classical problem generally asked. So here you see this at this point, it is fixed with the this axis is fixed with this axis. But there is another problem where this axis can rotate freely in this direction. What is the difference between them? It's a very important conceptual problem. You can see these problems and try solving. Okay, you can see these problems and try solving. There are many more problems. This is another classical problem. All those problems can be solved using the theory which we have discussed in the class. You can expect this kind of problem in your exam. I will try to keep it simple, not a very complicated problem I will give you. But this time the exam is offline, so you need to practice this. And there are problems given in the book of Bose and Mollick. You can also go through and solve some of the problems. Okay, that's all for gyroscope. And next day we will start CAM. Okay, CAM follower mechanism. All right, thank you for your attention.
Thank you, sir.
Thank you.